Hello science fans, Bill Nye here. Today, let's answer a classic chemistry question. Why is phenol more acidic than alcohol? In chemistry, an acid is a substance that can donate a proton, an H+ ion. The easier a molecule gives up its proton, the stronger the acid. After losing a proton, the molecule is left with a negative charge. If what's left behind is stable, the original molecule is a stronger acid. Both alcohols and phenols have a hydrogen attached to an oxygen, so both can act as acids. But phenol is much more willing to donate its proton than alcohol. Our mission: figure out why phenol is the stronger acid. Let's investigate by looking at their structures and what happens after they lose a proton. In chemistry, stability is everything. Meet our contenders. Alcohols like ethanol have an oxygen-hydrogen group attached to a simple carbon chain. Phenol also has an oxygen-hydrogen group, but it's attached to a benzene ring, a special, stable ring of 6 carbon atoms. This difference in structure is key. The benzene ring in phenol gives it unique properties. Alcohol's structure is simple. Phenol's is complex and aromatic. This structural difference is why their acidity is so different. Think of alcohol as a straight road, phenol as a roundabout with extra features. The benzene ring is the superstar here. Let's see what happens when each donates a proton. Alcohol loses its proton and becomes an ethoxide ion with a negative charge stuck on the oxygen. That charge is uncomfortable and unstable. Phenol, after losing its proton, forms a phenoxide ion. Here's the magic. The benzene ring lets the negative charge spread out. This sharing of charge is called delocalization. The phenoxide ion is much more stable because the charge isn't stuck in one place. Phenol is happy to lose its proton because the result is stable. Alcohol is reluctant since its ion is unstable. Stability makes phenol the stronger acid. Let's zoom in on this charge sharing, called resonance. In the phenoxide ion, the negative charge on oxygen spreads into the benzene ring. We can draw several resonance structures to show how the charge moves around. The real ion is a hybrid of all these structures with the charge smeared out. This lowers the energy and makes the ion stable. The ethoxide ion from alcohol can't do this. Its charge is stuck on oxygen. No benzene ring, no resonance, no extra stability. So, after losing a proton, phenol's ion is much more stable than alcohol's. Nature favors stability, so phenol donates its proton more easily. Resonance is the main reason phenol is more acidic. It's all about sharing the charge. That's the beauty of chemistry. There's one more factor, the inductive effect. In alcohol, the alkyl group pushes electrons toward oxygen, making the negative charge even less stable. Phenol's benzene ring, on the other hand, pulls electron density away, helping stabilize the negative charge. So, alcohol's structure makes its ion less stable, while phenol's structure makes its ion more stable. Phenol wins with both resonance and inductive effects. In summary, phenol is more acidic because its ion is stabilized by resonance and the benzene ring's electron withdrawing effect. Alcohol lacks both advantages. That's why phenol is the clear winner in acidity. Science is awesome.